the next group. Start to load it up. So it looks like a team of 4 here. So we've got from the University of Minnesota Twin Cities, we've got Emily Siem, Wallo, Thomas Lenz, and Alex Halatsis. I don't know who's going to be loading their screen, but if you would go ahead and get started, please do so.
Okay, can everybody see the screen? Okay.
Yep,
Yes.
Emily, you're good. Go ahead.
All right, thank you. Okay, so we are from the University of Minnesota Twin Cities, and we are a team of students who completed the project that Ben was just talking about. So we're going to kind of overview what our experience was like. I'm Emily. I'm an aerospace engineering sophomore, and I was kind of the XP organization and programming lead on the team.
Hi, my name is Siem. I was mostly doing the wiring and sensor testing.
And my name is Thomas, and I did most of the soldering and then the piloting, and also I worked on sample return.
And I don't think Alex is with us yet, so he can introduce himself if he's able to join later.
Yes. So I'll start us off. An overview of our kind of design plan to accomplish this task was, so we wanted the cameras. Tommy found this Raspberry Pi 0W and camera that could give us live feed video over the Wi-Fi. So we wanted to use that because it was a lot lighter than the drone camera, which actually allowed us to have 2 cameras on the drone when we flew it. And then for sensors, we wanted to have live data telemetry using XB3 radios so that when we were flying, we could kind of see the data coming in and say, oh, the magnetic field is really high over here, let's fly over here. And then some of the sensors that we had that we could fly, and we can kind of decide depending on what we saw in the area was an IMU, humidity sensor, LiDAR, temperature, UV light, visible light, pressure, and an altimeter. And then we also had a sample return design plan, which we will show in a few slides. So here's our designing. So some of the things we had to design was the wiring diagram for our soldered breadboard, which I think is in another picture. After we wired it, so you can see Siem made this. So it shows all the sensors and where they can plug into our breadboard, and then some of our prototyping for our sample return design. Siem, you're muted.
This is our soldered breadboard where we had our microcontrollers and all our sensors connected. It was mostly made of female headers, so we can plug in and out our sensors at a moment's notice. And it was powered by the drone through the hack cable you see down there. To mount this, we first thought of using a foam core platform where we'll put the platform on the legs of the drone, but we found that was too heavy. So instead we'll try using paper clips instead. But it was difficult to attach and reattach. So we finally landed on using Velcros, where we'll put the Velcro on the TNC and on the underbelly of the drone. And the other thing we had to design was our sample return. Originally, we wanted to use a servo and a pipette for our liquid and a servo and a straw for our granular solids. What would happen was the servo motor would squeeze the pipette and then collect the water. And for the granular solid, you stick in the straw and then close the hole of the straw using the servo motor. But to do this, we needed the XP and a microcontroller, and the whole system ended up being too heavy. So we moved on to a more passive choice where we had a container with holes in it to limit the amount of water we could put in it. And we would simply put a weight in there to sink this container in the water to collect it. And for the solid, we simply had a lid on this container and would drag this container across the granular solid to collect it.
So on our competition day, we put all these things to the test. So we had to design a plan of what we wanted to do, in what order we would do it. We had to adapt on the fly. So there was a couple things that didn't work. The day before we had issues with our cameras, so we had to, instead of recording the video with the Raspberry Pi, we had to record from the computer that it was broadcasting to. And then we had a computer die on us, so we had a couple of things that we had to adapt to. And then we had to fly in this environment that we did not know what it was going to be exactly. So we also had to sort of adapt on the fly with our sensors and things to what we saw in the field. And then finally, we had to get all our data collected together and present that in a way that made sense and in a way that was meaningful. So you can see, here's a couple of videos from our flight. We ended up having to mount the camera upside down, so that's why it looks a little bit weird. But on the right, you can see that's a video of the drone in flight from the side. And here's also just a quick little glance at our data. The one on the left is from our IMU that we had. And the ones on the right, there's a bucket in the flight area that we had a camera that was recording it, but then we went through and looked at the stills and saw that there was a pattern to the lights. I think it was like blue, green, and then red. So that was something that we didn't even notice while we were flying that's what was going on, but by sort of looking through our data, it was a pattern we noticed. We also had pictures of certain objects in the area, like that one in the middle left there. And then we constructed a map based on what we had in the video. We were able to tell how big we thought the area was. We had a lid in the frame that we went up like all the way to the top and took a video of the whole thing. And knowing how big that lid was, we could tell how big everything else was. So that's a little map that we made of our data.
I'll show if we go back a few slides. Yeah, right here. So here's when we went up and we took a picture from the top. And then we used this lid. Alex used this lid to calculate what the size of these other objects are from there. So that's how we did that.
Yeah, and actually you can see that that was the video from if you go back to the slide you were just on, that was, you can see it's in a web browser. Oh no, one previous. Yeah, you can see that that was actually from a web browser that we had the Pi video broadcasting to. Normally we'd have had like the video just in a video format, but we had to adapt, and so that was what we ended up with.
Yeah, so this is screen recorded from a computer screen. So I think that's all we have presented for. It was a little short, but you guys can have time to ask questions and we can re-go over stuff. And we also have the link up here to the consortium website that has information about the challenge.
Okay, great. Questions for our group? I can go ahead and start if for right now. What was something that you learned that you weren't expecting to discover as you're going through this process? I'll pose that to both of you.
I've got one thing that comes to mind right away, was that our servo plan for collecting samples was something that we had kind of been planning on the whole time. It was we had to figure out how to use the servos and how to use the teensy. And by the time that we had figured out how to get it to work, we'd spent kind of a great deal of time, but it ended up not being light enough to fly even. So that was something we learned, was that even though it was something that we had spent some time on, we had to adapt to the limitations that were given to us. And that flexibility was a big skill that we had to learn how to adapt and overcome. I don't know if Emily, if you've got something else, or Sam?
Yeah. I think one thing is just like how important communication is. You know, when you're working in a team like this, you know, it's really important that everybody knows, you know, what's everyone doing and, you know, where they at in the process, so that, you know, because originally we started off and then we're kind of learning about our sensors or whatever things we have, but then we have to come together and put that into a project.
Especially with COVID, you know, that was a huge thing. Was, you know, in a normal year, maybe we'd be able to meet weekly or 2 times a week or whenever we need to, but we had to be flexible and be able to work remote, and that made communication even more important.
So I have a question. Space Grant helped fund 10 teams around the state to do this competition with NASA money. Why would NASA be interested in this? I mean, are they really interested in toy drones, or is it different from that?
I think it's important not only for the reason Ben said about this applying to exploring outer space. It's also important for at least the underclassmen who just get into college, who are kind of interested in these things, and getting them to start doing stuff like this, hands-on stuff like this, is actually really good for them because they get to actually experience the things they're interested in, to see how they'll actually do it.
Great. Do we have some other questions from the audience here? I can ask another one as well too. So, what is one thing that if you had the opportunity to do, you would do differently?
I think one thing that we all kind of agreed, looking back on it, was that we spent kind of a lot of time planning things, and then it ended up some of the things didn't work out, and we had to quickly transition to new things. I think if we had to do one thing different, we'd try testing our things a little bit more early on, and do that so that we knew what was going to work and what wasn't going to work before we got too invested in it.
Specifically the sensors. I was gonna say, specifically the sensors, we didn't have enough tests with them actually in flight. We tested them while they were on the ground, but we didn't actually fly them while testing them. And a lot of time, and during the actual competition, we had a lot of problems with some of our sensors, and it wasted a lot of our time.
Yeah, I can definitely second that.
Following up, which sensors in particular were the ones that were problematic?
That would be on the day of competition, that would be the temperature sensor and humidity sensor. Both of them malfunctioned. So then we lost a lot of data from that. And then also the XB radios were, for most of the time, they were very reliable until the last couple of weeks before competition. They weren't working right, and then nothing would change, and then they start working. So for one flight they were working, and for one flight they were not. So they weren't as reliable as we hoped they would be.
Great. Well, thank you all. I think this is good pause. So we'll let's thank our speakers. Go ahead and stop the recording.